Part 6 – Best Practice Colour Measurement and Communication. Hopefully, by watching the videos earlier in this series, you already have some idea about the purpose and practical application of colour measurement. Whilst this short video series is in no means intended to provide you with an exhaustive guide, we hope that it can help you to understand the principles of a system which can improve the quality of your products, the vibrancy and consistency of product colour, and foster supply partnerships that work effectively to the benefit of all parties. Applying visual assessment, colour measurement, and digital colour data is at its heart a scientific endeavour. In the way that a colorimeter or spectrophotometer controls for the observer an illuminant, you'll get the most from colour data if you understand the weaknesses of processes and can implement a consistent approach and systems which, insofar as possible, control for the specification, production and approval of colour. Starting in the beginning, when colour is specified, it can be useful for both the producer and the customer to understand the common pitfalls and establish some processes to mitigate for these risks. A few days of collaboration and documentation can save far more time and resource if it prevents a subjective product reject or a tolerance that is unrealistic. The positive of engaging in this can be that from the first step you establish realistic expectations and demonstrate that you're an organisation committed to quality and collaboration. You should define the responsible people in each organisation and ensure that each is familiar with the expectations of the process for specification, approval and complaint handling. Ensure their colour vision has been tested using the Ishihara test and a Munsell 100Hue test. You could even show them this video series as an introduction to the project. When you use visual assessment in your processes, ensure that best practice is adhered to. Visual assessments and approvals should be performed in a colour viewing cabinet. That cabinet should be maintained per manufacturer's specification, free from clutter, and there should be no ambient light entering the cabinet. That includes the reflections from high reflective or brightly coloured clothing. Observers should view the sample from the same angle. A best practice checklist is available from Konica Minolta Sensing that covers best practice assessment in more detail. Check the link in the description to access a copy of that resource. When measuring samples, there are several factors to consider. Firstly, the instrument. You should use a measuring instrument with the same measurement geometry, the same size of measuring aperture, and the same illuminance. Konica Minolta Sensing's colour data software SpectraMagic NX2 includes a QC template mode, which allows the project owner to lock these measurement conditions to the digital colour data report file. It's not always necessary to utilise the same model of instrument if these criteria can be met, but you'll always achieve best results if you do. This is because instruments have an inter-instrument agreement, a tolerance of how closely they read to other instruments of the same model, and an inter-model agreement, which is how closely they measure compared to another model of instrument otherwise using the same conditions. The inter-model agreement will introduce the larger margin for error, but in some cases it can be an acceptable error. Inter-model agreement is influenced by the differences in geometry and the components and materials used in the different models. If you consider measuring your products with two different models of spectrophotometer, please check for inter-model agreement for each of your applications separately. Even though two models of spectrophotometer may show good correlation for one kind of product, it does not necessarily mean this is true for any other material or colour. Instruments should be maintained as per manufacturer's specification. Typically, this means that every year they're maintained, adjusted and calibrated against data that is traceable to international standards. This not only ensures that the instrument is in the best working condition, it also provides a certificate for your records and traceability for your measurement data. Calibration schedule and certificates should be part of your ongoing process to check and share with customers or suppliers. You should ensure that white and zero calibration are performed regularly. This calibrates the photometric scale. It should be noted that this is not the same as manufacturer calibration, which inspects performance against all wavelengths, using a set of traceable master standards specific to that instrument model, and provides the continued traceability for your instrument. If you want to check and record wavelength accuracy in the interval between manufacturer service, a green tile check system can be established within the SpectraMagic NX2 software's instrument check function. For help with this function, a tutorial video is available on the Konica Minolta Sensing website and our YouTube channel. Some modern instruments also feature a built-in wavelength analysis and adjustment function, which checks and automatically corrects wavelength accuracy each time you perform white calibration. When performing white calibration, you should check that the tile is the correct tile for that instrument, that it's in good condition and free from fingerprints, dirt and scratches. You should also regularly check your instrument, particularly the sphere, for any dirt or ingress. Never put anything inside the sphere to try and clean it. If any dirt enters the sphere, then the instrument should be sent to the manufacturer for service. The barium sulfate coating of the sphere is extremely fragile, and any damage can greatly affect measured data. Generally, you should always use the largest aperture you can for measurements. Only reduce the aperture size if the pattern on the sample, the size of the sample or the curvature of the sample necessitates a smaller aperture. If the aperture doesn't make full contact on a curve, then light escapes around the curvature of the sample when using larger apertures. You should pay attention to the actual measurement size of the aperture, as the abbreviated names SAV, MAV, LAV, etc. do not necessarily correspond to a particular spot size. When you measure samples, you should do so in the same way. This means measuring basically the same spot on the sample, with the device orientated the same way. You can agree with your supply partners if an averaging of 2 or more measurements is made, and what the measurement or escalation process is if a sample falls outside of tolerance to the target. You should also always measure with the same backing, as many samples which appear opaque aren't 100% opaque, and using a different material underneath can therefore impact the measured data. The same is also true for picking up the sample to measure. Not only does it make sample positioning and consistent contact with the sample more difficult, but it can introduce backing errors. If you're maintaining a set of physical standards, you should take pains to ensure they're protected. Physical samples should be free from dust and scratches. They should be carefully handled, avoiding fingerprints on the surfaces that you need to measure or assess visually. When not in use, they should be stored securely out of the light. Even small, gradual changes will eventually lead to a large deviation from the originally agreed target and can cause rejects. You should routinely check your master and working standards with a calibrated measuring instrument to validate their accuracy and acceptance to specification. For more information, visit the Konica Minolta Sensing website, speak with your local representative, and subscribe to this YouTube channel to be updated when new resources are added.
Konica Minolta.